Hola exploradores. Hoy te ofrecemos el segundo tema del curso de Iniciación a la Inteligencia Artificial. Este curso lo ofrece LinkedIn Learning, plataforma educativa de pago a la que puedes acceder desde tu perfil de LinkedIn. Sin embargo, este curso es totalmente gratuito, por lo que puedes acceder también directamente en su plataforma o bien visualizando nuestros vídeos. La propiedad y los derechos de este curso gratuito son de LinkedIn. En este segundo tema hablaremos del aprendizaje automático y de las redes neuronales artificiales. El aprendizaje automático es la capacidad de una máquina para aprender y mejorar automáticamente a partir de datos sin necesidad de ser programada explícitamente para cada tarea. El aprendizaje en las redes neuronales se logra mediante un proceso llamado entrenamiento. Durante el entrenamiento, se presentan a la red un conjunto de datos de entrada junto con las salidas esperadas. La red ajusta sus pesos y conexiones internas para minimizar la diferencia entre las salidas predichas y las salidas esperadas. Este proceso se repite hasta que la red neuronal alcanza un nivel de rendimiento satisfactorio. Recuerda activar los subtítulos si lo consideras necesario. Ya está todo listo para comenzar.
Imagine a computer that didn't need to be programmed. The system could learn the same way you do, just by observing the world. You've seen that earlier AI systems used a symbolic approach. The idea was that if the system recognized symbols, then it would start to seem intelligent. One of the key challenges was that programmers worked with experts to create the system. That's why they were called expert systems. Later, computer scientists gave up on this approach because it created too many combinations. They decided that you couldn't just program intelligence into a system, but maybe you could program a system to become intelligent through observation. It wouldn't feel, hear, see, or taste like a human. Instead, it would learn by sensing data. In 1959, a computer scientist named Arthur Samuel created a checkers program that could learn by playing against itself. It played both sides of the board and taught itself strategy through observation. The more the machine played, the more it saw patterns on how to win. Computer scientists didn't program the machine to play checkers, it learned through its own experience. Arthur Samuels called this idea machine learning. This was different from symbolic systems. No human programmed the moves and countermoves. Instead, the system was designed to learn and improve on its own. The system would quickly learn new checker strategies, and after a short period of time, it consistently beat its programmer. Machine learning was a breakthrough discovery. There was only one downside. These systems could play games, but in the 1950s, there wasn't that much digital data. Remember that machine learning uses data as its five senses, so without data, it could only find the simplest patterns. But that all changed at the beginning of the 1990s. The explosion of the internet suddenly had everyday people creating huge amounts of data. The 1990s was a time of explosive growth for machine learning systems. The new data was like water that poured over the dry fields of artificial intelligence. At this point, machine learning systems had the fuel they needed to become more intelligent. So if you wanted to teach the system on how to identify a cat, you had access to millions of cat pictures online. Computer scientists began to create newer machine learning algorithms. There were even some researchers that started to create systems that were designed to mimic the human brain. One of the big advantages of learning through data is that machines could continue to grow with more data. If the machine finds new patterns, it can adapt to the new information. But it's important to keep in mind that you still run into some of the same challenges. The machine learning system is still just identifying patterns. Still, in the last few years, machine learning has been the fastest growing area in AI. As the amount of data increases, this area has even shown more promise. Organizations are constantly collecting vast amounts of new data. So now the big challenge has become figuring out what to do with all this information. In a sense, you have artificial intelligence systems looking through your data and letting your organization see what it finds. Machine learning has gotten a big boost from artificial neural networks. An artificial neural network is an AI system that mimics the structure of the human brain. And it's currently one of the most popular approaches to machine learning. Think of it this way. When I was a kid, we used to play a game called Animal, Vegetable, or Mineral. The point of the game was simple. someone would think of an item, then all the other kids would ask questions about what the item was. We'd ask things like, does it have fur? Is it bigger than a house? Then in another round, we'd ask if it's alive. Does it make noise? After each round, we would start to zoom in to identify the item. Then at the end, we started making guesses. Is it a horse? Is it a cat? Is it a dog? An artificial neural network uses a very similar approach, except instead of asking questions, the neural network uses hundreds or even millions of numerical dials. Also, the network makes much more specific guesses. It would say that there's a 64% chance that it's a cat, or a 32% chance that it's a dog. To build the network, there's a row of neurons on the left called the input layer. Then there's a row of neurons on the right called the output layer. All the neurons in between are called the hidden layers. They're hidden because it's not the input or output. To start, we'd feed the input layer of the network a picture of a dog. We know it's a picture of a dog because we've labeled it. But the neural network doesn't look at these labels until it makes a guess, just like the animal, vegetable, mineral game. The network would then look at each dot in the image as it passes through the hidden layers. Then it makes a guess for the output layer. Let's say for the first guess, it says there's a 10% chance the image contains a dog. Then the network compares its guess to the label on the image. This is called training the neural network. Then the network goes backwards and adjusts the neuron dials so that it can see patterns in dog photos. Then it takes another dog image and sees if it gets closer. The neural network then tunes itself by looking at hundreds of thousands of pictures of dogs. Then it will adjust its own dials until it consistently guesses correctly. Now, it's important to keep in mind that the neural network isn't seeing the dog the same way you do. It doesn't think about panting, barking, or fur. Instead, the system only sees the dog as a recognizable pattern of dots in an image. When there's dots in a dog-like pattern, then the system makes a guess. Now remember that these neural networks are still machine learning systems, so the network needs access to huge amounts of data. If you don't have hundreds of thousands of pictures of dogs, then there's no way for that artificial neural network to learn. In the end, this is the key benefit of an artificial neural network. It can train itself to understand patterns and recognize that input when looking through massive amounts of data.